So today we're looking at the derivative of a log function. Now this is on your formula sheet now that you were given. So if we have a function y equals the log of x, we're talking about the natural log, so log base e, then the derivative of y with respect to x is equal to 1 over x. So generally you're not going to be asked to differentiate something quite that simple. We're going to have a look at a few examples. So we're given this function y equals 5x squared minus 7 log base e of x. So when we're differentiating this, then the way we do it is the way we've always done it. So the derivative of 5x squared, you bring down the 2, so you get 10x, and then you take 1 away from the power, so it leaves you with x. Then it's minus, now 7 is your constant, so that's out the front. And the derivative of log base e to the x is 1 over x. So then we just simplify that into 10x minus 7 over x. Now, ones like that are fairly straightforward. It's just one new part in the function. But question number 2, we have a function within a function. So you're using your function of a function rule. Okay, so if y equals log base e of 3x plus 4, your first step is to differentiate the log. So we know that this is 1 over 3x plus 4. So you just keep your function inside the brackets, and then you differentiate what's inside the brackets. So when you differentiate 3x plus 4, you get 3. And so this is equal to 3 over 3x plus 4. Now it doesn't matter how complicated that function inside the brackets is, you just differentiate your log, so you're going to get 1 over that, and then differentiate what's inside the brackets and multiply by that derivative. Okay? Now looking at number 3, this one, x cubed log base e to the x, this is a product rule question. So if you have forgotten that, go back, double check it. You need to know your product rule, your function of a function rule, your chain rule, and your quotient rule. Okay? So let's have a look. For the product rule, we let u equal to x cubed. So the derivative is 3x squared. We let v equal to log e to the x. So v dash is 1 over x. And then we substitute it in. So when we differentiate f of x, we get now remember, this is uv dash plus vu dash. Product rule is plus. So that's x cubed times 1 over x plus log base e to the x times 3x squared. And then you need to tidy that up. So x cubed times 1 over x is x squared plus. Now it's this whole log function that's been multiplied by 3x squared, not the x within the log. Be very, very careful there, okay? So 3x squared outside of log e to the x. So I'm going to take out my common factor of x squared outside of 1 plus 3 log of x. Okay? So if they ask you to differentiate it, that's it. But when is this most useful? When we're asked to find the gradient of a tangent or the equation of a tangent and something like that. So remember, as soon as you see gradient of the tangent or equation of the tangent, that means you need to differentiate. Okay? So we start off with log base e of x squared plus 4. Looks complicated, but just remember, you take it one step at a time and do everything that you already know how to do. Okay, so when you differentiate y, we end up with, well, it's a log function, so that means we're going to have 1 over, then we have what is inside the brackets, and then we are multiplying that by the derivative of what's inside the brackets, and the derivative of x squared plus 4 is 2x. So then tidy this up. We end up with 2x all over x squared plus 4. Now I want you to consider that for a moment, because in the next lesson that becomes very important. What we have is a function in the denominator, x squared plus 4, and we have the derivative of that function in the numerator. And that's going to become very important when we're integrating functions, because remember, integration is the opposite of differentiation. So I know that if I differentiate a log, I end up with a function on the bottom and the derivative of it on the top. Integration, well, if I see something like that, then I know that it comes from a log. Okay? Anyway, so we know that the derivative of log base e x squared plus 4 is 2x over x squared plus 4. But they want to know at the point x equals 5, what is the gradient? So at x equals 5, my gradient is equal to 2 times 5 all over 5 squared plus 9. That's equal to, sorry, 5 squared plus 4. So that is equal to 10 over 29. So at the point x equals to 5, the gradient of the tangent is 10 over 29. That's what you need for exercise 4.7. Question 1, make sure you do a bit of a mix, and then do the questions listed on your sheet. Good luck, I'll see you in class.